Good evening. Hello, everybody. My name is Olga. I have the honor of represent the Sabit company and welcome you to this event. Our company is distributor of Rhinoceros 3D and authorized McNeil Training Center. We have been providing Rhinoceros 3D and K-Rhino add-ons since 2013. Our services include technical support, user training, and an all-around implementation of 3D technologies in Rhino. Today we have which will be conducted by Natalie Khadyakova. We are supposed to finish the event more or less in 1 hour. Natalie is a landscape urbanist, computational designer, and educator. She holds a master's degree from the Architectural Association. Now she co-founded IMIA Studio and works as a computational designer at Jallis Miller Studio. Natalie has taught in UCL, Ballet, Bipro, Digital Futures, Architectural Association, and Warsaw Polytechnic. Now I would like to pass the word to Natalie. Please.
Hello, thank you. Thank you, Olga, for the introduction. Yeah, thank you all for coming. Well, I think I'll start with sharing my screen. Olga, if you let me be a co-host so I can share my screen, that would be really helpful. Thank you. Okay, so do you see my screen, everyone? So just, wave or do something so I know that you see the screen. And you're here. If you can switch on the cameras so I can, okay, thanks. Marina, thank you. So I can see you, that would be great. If not, that's fine. So, okay, so I would talk today a bit about my work and about this nature and technology combination. And what we are doing is looking for a third entity between nature and technology. And so a bit about myself. As Olga mentioned already, I'm an architect, landscape urbanist, computational designer, and artist partially as well. And I work with this merge of the nature and bio-inspired megastructures, as we call it sometimes, and with technological part, with computational design, with building algorithms, and trying to source how those natural patterns are being actually created, and then trying to develop design and architecture basing on those algorithms, let's say. And I also spend a lot of time in education because I just love sharing my knowledge with people. And yeah, so I was teaching in few universities and also was giving lots of lectures and workshops in a private, let's say, manner. And now with this collaboration with Rhino 3D, I think is really valuable as well. And now as a professional, I actually affiliate with two entities. Is the IMA Studio, which I co-found with my colleague Katya Bryskina, and the other one is Jallis Miller Studio, where I work as a computational designer and artist, and I help to develop the algorithms to create those sculptures, surfaces, and architectural works as well. And this particular masterclass was inspired by the idea. Sorry, I'm gonna put light a bit. Yeah. So this masterclass was inspired with this workshop today was inspired by the idea to create a 3D course online about the bio-inspired design and the algorithms in Grasshopper of the bio-inspired shapes that I usually create. And because at some point I realized that I developed a pretty nice workflow to create pretty weird shapes actually in Grasshopper and Rhino, which are at some point I understood are being considered as kind of unique shapes and works when I share it somewhere. And I thought that probably it would be nice and worth to do that just to create a separate course and to put this like I think I would divide it into 3 blocks where I will speak about the agent-based systems, how we work with them and how we create shapes from them. And then a bit about the bio-inspired shapes with other algorithms, and then how to actually make those things, how to build them, how to produce them, because the projects I will be showing today are mostly physical and implemented projects, which I think is also really nice because, you know, to just develop an algorithm to create beautiful renders is one thing, and then to produce the actual shapes from it is something really different. And sometimes it never goes to this stage, basically. So what I really love about working within IMA and Giles Miller, that we actually find ways and materials to build our things. I had something else to say here. Oh yeah, so yeah, about this workshop today. So I will be speaking for around, I don't know, 40 minutes, something like that, and maybe even less. And then we'll try to create a really, really simple algorithm in Grasshopper. So if you have Grasshopper and Rhino open and installed, that would be great. So you can just follow the really, really fast tutorial that I will be giving, because it's just a pretty simple code, but it gives lots of opportunities and it's pretty fun, basically. So what you will need is Rhino, Grasshopper, and some image, but I will show later. Okay, so first of all, I wanted to say that I am actually trained as a urban planner, urban designer and landscape urbanist. And I started with working with the big scale projects, and I think probably some of you have heard about these projects already, but I will still talk about them. So the Shifting Arctic Boundaries project was done during my studies at Architectural Association School of Architecture in London, and we did that together with Penny Fita, where we were looking into the different mentalities and how different, let's say, cultural perception of the landscape by different nations and peoples are actually being reflected in the territorial scale, in the actual territory, and how people actually treat the landscape. So within this atlas, we developed a map of 2 different mentalities, let's say. So the first one was of the indigenous peoples of the Arctic and their movements, which is on land, represented by different colors and also with the black arrows. And because they are still nomadic or semi-nomadic, and they travel to the coast and then to inland in different seasons. And at the same moment, there is also a global Western mentality, which is coming into the Arctic, and with the oil and gas resources, and also the shipping routes, and also not only oil and gas, there are lots of resources actually in the Arctic, and they are currently being developed more and more, and especially with the ice melting. And we then we're trying to zoom in to look into more local scale, how this is being reflected in the more regional scale, looking into the European part. And we developed a map of those nomadic people, actually area of activity. So because they don't have borders as such, they don't really use the notion of border because they travel. So in this case, they are more about the activity, which is like the territory which is more occupied and then less occupied, and like being less used or more used. And then this confronts again with the another mentality of the boundaries and the borders of the countries, because basically sometimes they are being really separated by the state border, like in this example, for example, with Russian part and then the European part. So the land that was before occupied by Sami people, in this case, this is the peoples that are living in the Scandinavia and Kola Peninsula. And then we again zoomed into the northwestern part of Norway, and we looked into one peninsula where different like ports and for oil and gas, mostly shipping routes were being developed, and where their projects being developed, and how this all also clashed with the local Sami peoples living, because they herd reindeer, and those reindeer are also using this peninsula. And there's also a military zone because Russia is nearby, and this is the border between the Western and Eastern world, let's say. And also there is an airport and also touristic routes. So everything is really clashing. And so yeah, why I'm showing all this to you when I'm talking about computational design. So basically, what we thought then, how technologies can actually try to help to solve those issues between different nations, different peoples, and different territory actors. Like in this case, there are lots of actors using the same plot of land. And we thought that inspiration would be in the landscape features, and in nature, basically. And also in this culture of local people, which are living with connection with the landscape, and in connection with the landscape. And they are basically they were using this inspiration from the landscape as their territorial formation and their mentality and their culture. And so we developed this tool, which is being inspired by shifting boundaries, by moving boundaries, and we coded this landscape features, which are important for each actor. For example, in this case, the boundaries of the reindeer herding units are running, excuse me, and they are running depending on the landscape features that are important for reindeer. For example, there is a pasture land or forest where these boundaries can expand. And basically with the sliders on the top left, we can adjust the size of the unit for reindeer, and then the boundaries will start to run, and they will start to adjust and adopt these new inputs. So we were thinking that in this case, this tool can be as a negotiation tool between different actors on this peninsula, where people can sit together and they can run some sliders and then can make decisions beforehand, before they are using the actual land. And then, yeah, we proposed different scenarios for the land usage and how those ports that I was talking before were they are being designed there. They are not there still. And how with the building of those ports, those land plots allocated to each actor can actually shift and can change. And another work would be about the Tallinn Architecture Biennale Pavilion, where it was an architectural work, but we were also looking into how to co-design with nature, how to be inspired by nature, but also how we can build the objects with some natural forces. Because basically what I was trying to show in the previous project in particular is how we can use nature as an inspiration, how we can source some inspiration from natural dynamic processes, and then how we can co-design with it, not against it. And basically, in this case, there is an incubator inside this pavilion where the robot designs with mycelium. Mycelium is the fibrous structure, is a root system of mushrooms, let's say, which is always underground. And it grows only in the dark because it is an underground structure. And that's why we needed to shade this incubator. And that's why we built this kind of a structural pavilion, which has those curtains where you can enter from each side and go towards the incubator. And the incubator is designed that way that there is a robot which moves. The algorithm of this robot movement is kind of resembles the spirograph, and robot adjusts the speed of the movement according to the mycelium growth, because it's also seasonal, because this should be an underground structure. It was designed as outdoor structure. It was designed, and therefore in different seasons the mycelium will grow differently, and then the robot will adjust to its speed. So this is the plan, and then we were looking into different patterns of the mycelium growth and how actually it behaves. And like my colleague Katja Briskina, she was doing lots of photos of the incubator, which was the mycelium where was growing. And it was really fascinating, actually, to learn from those algorithms how mycelium is first occupying all space and trying to reach every spot available for like the source of food. And we were thinking like this is the first stage of the mycelium growth. So it tries to reach as much as it can with really, really tiny structures and connections. And then it understands where there is a source of water or source of food. And then those connections are being forced, and they have more strength and they grow more. And then the rest they start actually to degrade slowly. And then there are different behaviors in different conditions. And As you can see on the photos, there are lots of different structures. And then basing on this knowledge and learning from the model and from the mycelium growth, from this inspiration, we built a few scripts which were actually describing the growth of like this pattern that I was actually explaining before. And we were thinking that basically it is a nice script, and it can be modified in different ways to serve different aims, actually. And actually, we were first even thinking that we could do that for the urban planning, where again, like for the, I don't know, transportation connection and pedestrian connections, where we start from connecting all dots with all dots, and then we can basically strengthen the ones that are really needed, and then the rest can slowly degrade. And we were also building the models and trying to render how this mycelium will slowly occupy the model. So we were really playing a lot with this algorithm. And also we had a workshop at Digital Futures where we gave this grasshopper algorithm to students, and it went wild at some point. They were really saying like this script is designing for us, because it really grows like it's being alive, which was really nice, actually. So that they were using the script in a really different manner. But what was really interesting for me is that then we were using basically this knowledge to create those shapes for the London-based artist Marguerite Himo. We were doing the computational design help for her, and we were developing the algorithms for different structures that she is building. So she was inspired by termites, and she was in Australia. She was actually photographing them a lot. And then she was really inspired by those structures and by those, let's say, agent-based insects like bees or termites or ants. And she was thinking how to develop different structures. Of course, she had a really long brief, but we thought that basically this mycelium algorithm can also be adjusted and adopted to generate the termite towers, which actually worked well. And we were basically developing those different shapes for her exhibition. And then, yeah, based on this 3D model, so she was producing them. And then we were also, she called us also to help her in the next exhibition, which was about the root system. And then we understood that this algorithm can also be used to create the roots, which is also the, let's say, mycelium type structure, which can be quite applicable in this case. And then there is another algorithm and another, let's say, piece of inspiration and work that we were doing at IMI Studio is those nature-inspired structures that we were developing again in Rhino and Grasshopper. Which started from the inspiration from Midjourney. So we basically were just prompting some mussel or shells inspired objects and interior objects, because the aim was to design the storage for tiny things, or like a display for jewelry, like something like that. So this was our intention first, and we also wanted to use the PLA, which contains mussel shells or oyster shells, to 3D print those objects. So that's why we were actually trying to design the objects which would resemble some seashell structures. And so we started from designing them with Midjourney, and later on converting those images into 3D shapes with Grasshopper. And then a bit of polishing, of course, and meshing and remeshing. But then we were able to 3D print those structures, which they are not really big. They are like small structures, and they can be 3D printed in a with a really simple Prusa, for example, 3D printer. But then we went on to, I think there was a video in previous slide. So then we went on to expand, because we were actually preparing an event for the presentation of a big project that we were doing at the studio. And we needed serving plates for the dishes, and also for different objects on the table, and those objects should be much bigger. So we again started with designing those objects in Midjourney and getting inspiration from some things that we could actually form there. And after that, we again, using Rhino and Grasshopper, converted them into 3D shapes and 3D printed them. I think this is the video again. Yeah, so now this was in FabLab, so this was a huge 3D printer. And we were also using another one, again in big studio, which is Space Caviar, and the previous one was Carlo Ratti Society. So we were using the paste from mussel shells. It's like a cement structure, and which is 100% natural. So it consists of 98% mussel shells. Yeah. So yeah, so those were this was another iteration of those objects, which have this technical, let's say, workflow, starting from the AI generated image, going into Rhino and Grasshopper to convert into this 3D shape, then a bit of polishing and remeshing, and we used that brush, but that can be any other program, basically. And later on, 3D printing, or 3D printing with a clay printer, as in this case. And the last bit is another way of fabricating and creating the objects, which also are organically shaped, and they also have they are inspired a lot by nature. And also at Giles Milner Studio, we work with the materiality of things a lot, trying to use as much as possible natural materials, or resourcing, reusing materials, so making the footprint and harm for nature as less as possible for those artworks, at the same time keeping the artworks quite unique and yeah, high level design, let's say. So this project was one of the first ones with the it was the interior structure with which separated the inner space from the outer space, and the petals were rotated the way that from the outside you couldn't see what is happening on the second floor, and from the outside, from the inside, you can see everything. So it also had like a functional purpose in this case. And so basically we are starting from the surface, and the surface itself is also being sometimes generated within Grasshopper, trying to see the space and how this space can be designed, how it can accommodate the structure. And then everything is done in Grasshopper, basically. So I would say that like everything just comes out of Grasshopper and it goes to laser cut and then is being produced by the manufacturer. So in this case, it's really nice that there is basically no one in between the production process and the designer and generation process. And I think it takes a lot of responsibility, because if, for example, if I make mistake, there is like no one in between, because it just goes there. Of course, the manufacturer checks the 3D model and the drawings for consistency, but still, it's it's not on them; it's on me or on our team within Giles Miller. And another work was pretty difficult one, although it's just a repetitive pattern of the same wavy, let's say, section of the facade. But then the idea was that the front part of the facade would open and close, because it was BBC Pavilion in Cannes, and they had like a screen, and they wanted to show this screen sometimes and then to close this screen in most times. And the difficulty was that when open, the petals were like in checkerboard, and it was fine. But then when closing, they start to clash and intersect, which is not acceptable. So it was a really long script to build to create the clashing points detection in the script, and then to dynamically open and close and to check if there are still intersections. And because we needed to sort out intersection in the, let's say, narrow position. But then when we widen it up, we see that there are like big spots of holes on the facade, which is not acceptable, of course. So we needed to spread them out again. And that was I think the most difficult part in this case, because all the rest we knew how to do, because we did the Veil project before. But it was really interesting to build this script and to develop the algorithm for those petals movement for the intersection detection. And then we built the whole model, the whole 3D model of the pavilion facade, and then created the drawings for the laser cut production. And yeah, the pavilion was built, and then it's in Cannes. I'm not sure like if it's still there, but they were disassembling and assembling it every year for the exhibition. So it was reused a lot. And the next project was I want to show you today is this is the place in Mumbai, and this is a parking zone in the skyscraper in Mumbai, and the facade is huge. I think it's 76 meters or something. Like it's big, and it was interesting that we needed to build this idea of a really random shimmering, let's say, facade structure. But of course, it needs to be optimized. So all this randomness was created only by 5 different types of the petals, the details. So you can see on the left. So we needed to randomly allocate them, to shuffle them along the facade, and then to sort them out, to mark each panel, which petals are used in each panel, which was also a really interesting algorithmic task, say, for me. And yeah, as I was saying, what I really love about this work, and I think all works that I was showing today, they all have this in common. So what you see in the model, you basically see on the photo in the real project afterwards. It's just the same, and sometimes it's really funny because like in this example with Marguerite Humeau sculptures, it's really interesting because she is taking like bits and pieces from different codes, she's combining them together, she's just developing her structures, which because she is really like a talented and professional artist. And then you see the final sculpture in the exhibition, and you're like, and this is the part of my code. I really remember this exact thing was in my model. So this is really interesting with this kind of workflow, let's say. Yeah. What I was also like, those are 2 objects we were designing for a competition in Ireland. Also really nice examples of the pavilions, but they were not built, unfortunately. maybe someday. Right. So I think maybe you have some questions, and maybe we can move on, and I can show you the script. Like, I guess.
Yes, I have a couple of questions.
I don't hear. I don't know. Just a second. Yeah, I hear. Okay.
Everything's
Yeah.
okay?
Yep.
First of all, thanks, Natalie. Very interesting and valuable for me right now. So my questions are, I'm interested about the mixture of these mussel shells, which you like 3D printed from. You said it's like 98% like natural constants. So what's the clue, or I mean, what's the clue? What's the liquid part of this? As understood, you just like drop the mussel shells in the blender, just like make it powder from it. But what's the liquid part of it? How it's
It's
like
sodium alginate. It's from algae, so it's basically 100% natural.
from? Okay, I understood.
Yeah. Yeah.
And
If you know the website Materium,
Mhm.
there are really nice. Just a sec. Yeah. So there are really good recipes on this website, which you can use. I probably can, yeah, capture it here. I think it's org. I'm not sure.
I see.
Okay.
Okay, yeah, thank you. And the second one about your previous project for BBC Studios and as understood on the coast. I saw that animation that facade was opened like on both sides. I mean, like on the right and the left, but from the one point. Is the facade like moving from only that point, or it can like be open from different points? I mean, not from only from the center, maybe like from the left part or like. Did you understand it?
No, yeah, I understand. I think in this particular case, it was opening only from the center because the
Okay.
screen should be in the center.
Okay.
Yeah, and but basically for the way how we developed the moving parts, I think it could be different. It's just the matter of the construction rail where it moves.
Okay, I get it. Thank you.
Thank you. Okay, so if you don't have any more questions, I think I can quickly show you the script. Maybe I will even open it. So it's basically being inspired by what I was showing. Sorry, I need to go to browser. What I was showing you with the storage, with the carbon storage, and this object which were 3D printed. So it is pretty simple, but it's good if you have any image that you want to make a 3D. So yeah, I will probably not share with you anything. It's just for you to check to choose what you want to use. So basically, we need a grid of points. So let's create a grid. And you can set up number of points, the size of the grid, because we need the points. And then we choose the image. Yeah, I think I will copy the one that I have. So I just picked a random image. It's a photo, basically. And then we go into settings. And we state the color brightness, so to make it black and white. And then we also need to set up the X and Y domains for the image size, which will be needed later. But it's good if we have it from the very beginning. So for that, we need to understand the size of our frame, because the image size that we will set up will follow the same size of the grid that we have. And we even can adjust it because the image is not exactly squared, it's rectangular. So we can basically yeah, let's make it 70 and 50. That's fine. Yeah, now we need to measure the actual size in Rhino units. Let's do that parametrically. So we can call for bounding box. And then we right click and we make the union box. And we also flatten the input. So all of our grid cells will be flattened. And then we have just one box as an output. And then we need the dimensions. And when we have the dimensions, we can just see them with the panel. So now we go to settings of the image, and we set up the X domain into 70 and then the Y domain into 50. Okay, so now we have the image, and then we need to input the points into it. So we just put it from the grid. And then we move them up. We move the points, the original ones. We'll switch this off so they will not interfere. And the way how we move them, we want that to depend on the color of the pixel. But in this case, like from white to black. So this gradation. So we will do the multiplication to have a bit of control, basically, on the height. And then we go to vector amplitude. And we use Z vector in this case because we have the grid located in X and Y orientation. And we move the points. And you already can see that we have our image in 3D. And then let's flatten them, and then let's create a surface. Oops. I have the, okay. Oh. Surface from points. This one. So we need to take the same amount of points we have. Yeah, +1. Okay, here we go. We have our output. And we can play now with the height parameter to change the way how we actually extrude those points. We can also make it negative. And we'll have it in the, like now it will be convex. Yep. So that's basically it. As I said, it's quite simple, but it gives, I think, lots of opportunities with creating nice organic shapes and playing with the different designs, and even for the bigger scale structures for master planning, I think they can also work well. If you want me to stop at some point, I don't know if it was possible to follow this short tutorial, or maybe since we are recording this, so basically I think you could later on see the recording. Yeah, so please let me know if you have any more questions, or you want me, I don't know, to expand on something which I was talking today. I will be happy to answer your questions today, and also, yeah, we'll work on this online course, and we'll publish it, and you can already see the course page on rhino3d.online, and you can see the course structure, and you can actually consider if you're interested in it. You can also ask your questions through the form on the website, and reach me if you want. I think that's it from my side, and thank you all for coming this evening. Yeah, was happy to see you all.
Thank you.
Thank you so much. Yeah. Yep. Thank you. Yeah, I'll wait for a bit, but I think that's it, right?